Like the majority of the systems on the A330, the air conditioning system is fully automatic and is designed to provide a comfortable atmosphere for working and traveling. We will begin our study of the system by first looking at the air conditioning packs.
The A330 is equipped with two air conditioning packs, located in the belly fairing, just forward of the landing gear bay. Let's look at how a pack works. Hot bleed air enters the pack via a pack flow control valve. Its function is to adjust the flow rate through the pack.
The air then passes through several stages within the pack: heat exchangers and air cycle machine, so that it is cooled to provide a conditioned air output. In fact, sub-zero temperatures can be achieved.
Two of the stages are heat exchangers. They cool the hot bleed air using the flowing ambient air. This flow of air enters via the ram air inlet flap and exits via the ram air outlet flap.
A temperature control valve is fitted and can modify the pack outlet temperature by adding uncooled air to the turbine outlet flow. The pack flow control valve and the temperature control valve are regulated by a pack controller to vary the flow rate and the temperature output.
The pack controller also controls the ram air inlet and outlet flaps to adjust the amount of air blowing through the heat exchangers. Note: the ram air inlet flaps close during takeoff and landing to avoid ingestion of foreign matter.
To make things simpler, let's define the area within the black box as a pack. The two air conditioning packs operate automatically and independently to provide cool, conditioned air. The conditioned air from the packs is then fed to a mixing unit. In case of failure of both packs, an emergency air supply is provided via a ram air valve to ventilate the cockpit and the cabin or to remove smoke. Various pack parameters are monitored by ECAM. They are pack flow, compressor outlet temperature, temperature control valve position, and pack outlet temperature.
These parameters with the valve positions are displayed on the upper part of the ECAM bleed page. Having discussed the air conditioning packs, we will now look at how temperature and flow regulation is achieved throughout the aircraft. The 4 outputs from the mixing unit feed 4 separate aircraft zones: the cockpit, the forward cabin, the mid-cabin and the aft cabin. Let's look at how the temperature of the zones is controlled.
A zone controller monitors the temperature of the 4 zones and sends signals to the pack controllers to set the air temperature delivered by the packs. Normally, cold air is delivered by the packs and is then sent to the 4 zones. Since the different areas of the aircraft may require different amounts of cooling or heating, hot bleed air can be added via trim air valves to achieve the demanded temperature for a zone. These valves are controlled by the zone controller.
In the example shown, no hot air is being added to the cockpit in the forward cabin zone. Some hot air is being added to the mid-cabin zone and a lot of hot air is being added to the aft cabin zone.
The trim air valves are supplied via 2 hot air valves. These valves regulate the pressure of the hot air supplied to the trim air system for optimized temperature regulation. A hot air cross valve is also fitted. It automatically opens when a hot air supply fails.
Zone duct temperature, which is the temperature of the air entering a zone, the zone temperature itself, and all of the system valves are monitored by the zone controller.
The trim air system, the hot air system, the zone duct temperature, and the zone temperature indications are all displayed on the ECAM conditioning page. The ECAM cruise page also displays the zone temperature indications. The air panel on the overhead panel allows the pilot to control the air conditioning system. Let's look at the controls on this panel in a little more detail. The pack push-button switches control their associated pack flow control valves.
The pack flow selector is used to select the needed pack flow.
The guarded ram air push-button switch controls the emergency ram air inlet valve. In the example shown, this valve is closed. The use of the ram air push-button switch is restricted to abnormal conditions and will be discussed later. Each hot air push-button switch controls its respective hot air valve. In the example shown, the valves are open. Now let's look at temperature control.
The zone temperature selectors are used to adjust the required temperature for the associated zone, cockpit and cabin. Note, each cabin zone temperature can be optimized through the forward attendant panel. Two cabin fans are installed to recycle cabin air and air for safe fuel. They are used to blow air from cabin to avionics and to the mixing unit through two recirculation valves. Note, in normal operation, there are no ECAM indications linked to the cabin fans. Also, the two recirculation valves will partially close if both pack are lost.
A cabin fan's push-button switch on the ventilation panel of the overhead panel controls the cabin fans. This push-button switch can be used to switch the fans off in response to an ECAM procedure.